Hi everyone, this is Mrs. J, and today we're going to learn how to use Pythagorean identities. So we're going to start by proving what are called our Pythagorean identities. So this, you can tell by the name that we're going to be using the concepts used in the Pythagorean theorem, so a squared plus b squared equals c squared for a right triangle. So here you can see we have a unit circle. We know this is a unit circle because we can see that the length of the radius is 1. So let's just take any point on our unit circle. We'll call this xy. So if you turn that point into a right triangle like this, if you connect the center of your circle to the coordinate, that length is going to be 1 because, again, it's a unit circle. And this length is just x, and this length is y. And we'll call this angle theta. So earlier in this unit, we talked about how we could use the coordinates of a unit circle to help us evaluate trig expressions, because if you do some SOHCAHTOA with this angle, we know that the sine of theta is opposite over hypotenuse, so it's y over 1, which is just y, and the cosine of theta, which is adjacent over hypotenuse, would just be x. We also found that we could do the same for tangent. So we could say tangent of theta is y over x, which is opposite over adjacent. Or we could also say that the tangent of theta is sine of theta over cosine of theta, because y is equal to the sine of theta and x is equal to the cosine of theta. So now we know different ways to define these two lengths. Let's look back at our right triangle. We can do Pythagorean theorem with this triangle because it is a right triangle. So we could say that x squared plus y squared equals 1 squared, which is 1. And then we could substitute what we know x and y are equal to. So we know x is cosine squared and y is sine squared. So we could rewrite this as sine squared theta plus cosine squared theta equals 1. And I understand that x is cosine and the y is sine, but if you're doing the sum of two different terms, it doesn't matter what order you write it in, and you typically see it written in this order, although it really doesn't matter if you write cosine squared first or sine squared first. So this is one of our Pythagorean identities. So this is definitely something you're going to be working with a lot next year in pre-calculus. It's a really, really important identity to know. So this is I would say it's kind of like the primary Pythagorean identity, because there are other Pythagorean identities that we can derive from this. But before we do that, it's really common to take this Pythagorean identity and kind of write it in different ways. So it's really common to take this and maybe write it as sine squared theta equals 1 minus cosine squared theta. So again, you can see it's really the same identity, just rewritten in a different way. But you'll see this form a lot. This can be really useful for us depending on what we're trying to do. And we can even solve for sine completely. So we could describe sine of theta in terms of cosine by taking the plus or minus square root of both sides. So this is kind of a version of this Pythagorean identity that we're actually going to be using today. So again, it really just comes from the original Pythagorean identity above, but it's just the terms are moved around and written a little bit differently. We could do the same for cosine squared. We could isolate cosine squared and say that it's equal to 1 minus sine squared theta. Again, this is a really common identity that you'll see. It's really just a form of this identity, or we could solve completely for cosine squared, or for cosine by taking the plus or minus square root of both sides. So we'll be using this form of our identity today as well. So there are actually two other Pythagorean identities that I want us to derive really quickly, and we're going to use this original sine squared plus cosine squared equals 1 to find the other two. So let's start with this one here. So let's imagine I took this identity and we divide both sides by cosine squared. So I'm going to divide every term on both sides by cosine squared. Well, we know that sine over cosine is tangent, so that means that sine squared over cosine squared is simply tangent squared. And anything divided by itself is 1. And here, this is the reciprocal. 1 over cosine squared will be the reciprocal function, and the reciprocal function of cosine is secant. So this actually just becomes secant squared theta. So this is our another one of our Pythagorean identities. So this is definitely one that you'll need to know next year. We won't be using it as much this year, but it's also very common to have different rewrites of this. Maybe we say tangent squared is secant squared minus 1, or we could even say secant squared minus tangent squared equals 1. So it's common to see different forms of this identity. And now let's find the third Pythagorean identity. So we're going to go back to our first one here. We're going to kind of do that same process, but this time let's divide all of our terms by sine squared. So anything divided by itself is 1. And here, cosine over sine would be the reciprocal of sine over cosine. Well, sine over cosine is tangent, so cosine over sine must be cotangent. So this becomes cotangent squared. And then 1 over sine squared, you would use the reciprocal function, which is cosecant. So it becomes cosecant squared theta. So this is our third Pythagorean identity. And again, it's common to see different forms of this identity, like cotangent squared equals cosecant squared minus 1, just like we saw with our other two identities. So I'm going to highlight these. So these are, again, our 3 Pythagorean identities, and we can derive them using the Pythagorean theorem and a basic unit circle. All right, so let's see if we can use these Pythagorean identities to help us with these next few examples. So here we are told that the sine of theta is 0.766 and that theta is between 0 and pi over 2. They would like us to find cosine of that angle. So first, let's look at this piece of information. When they tell us that theta is between 0 and pi over 2, remember in radians, this is 0, this is pi, so this is pi over 2, and this is 3 pi over 2, and we would also call this 2 pi. It's a coterminal angle. So when they say that theta is between 0 and pi over 2, what we're saying is that this angle is in quadrant 1. So why do we care which quadrant it's in? Because we need to know if our answer here should be positive or negative. So remember this little trick. Remember, all students take calculus. This tells us which functions are positive in each quadrant. So in quadrant 1, all of our functions are positive, so the cosine of this angle will be a positive value. So if we know the sine of theta, the value for the sine of theta, we can use our Pythagorean identity to help us find the cosine of that same angle. So I'm going to use this version. So cosine theta equals plus or minus square root of 1 minus sine squared theta. So it's that rewrite of that first Pythagorean identity we found. And again, since it's in quadrant 1, we're just going to use the positive answer. And we're going to substitute what we know. So it's just going to be the positive square root of 1 minus, well, we're just going to substitute this, and we square it. And then here, we're just going to plug this into our calculator to get our decimal approximation. And we should get approximately 0.643 if I round to the nearest thousandths. There you have it. So we used our Pythagorean identity to help us find the cosine of theta given sine of theta. Now let's look at part B. So here we are told that the cosine of theta is negative 0.906, and we are told that theta is between pi and 3 pi over 2. So that means that we are going to be working in quadrant 3, which means I'm going to look at quadrant 3 and I see that only tangent is positive. So I know that sine of theta is going to be negative in that quadrant. So now, since I'm solving for sine, or I want to know what sine of theta is, I'm going to be using this form of our Pythagorean identity. And again, since it's in quadrant 3 and we're solving for sine, we are going to use the negative. Our answer should be negative. And then we're going to substitute what we know for cosine of theta. So negative 0.906 squared. And we'll plug this into our calculator to get our decimal approximation. And you should get approximately negative 0.423. And there you have it. All right, I have a couple for you to try on your own, so please pause the video and hit play when you're ready to check. All right, go ahead and check your work here. Really the most important thing to look at for these, it's really just plugging in values, but you do need to look at which quadrant you're working in to see if your answer should be positive or negative. So for part A, we are in quadrant 2, so sine is positive in quadrant 2. Cosine is negative, but our answer should be positive because we're solving for the sine of theta. And for part B, we are in quadrant 3, so cosine will be negative in that quadrant. All right, so now we're going to see if we can find cosine and sine of theta given tangent of theta. So there's actually a few different ways we can go about this using our Pythagorean identities. Okay, let's say first we start with just the basic identity that the tangent of theta equals sine over cosine. So here I could solve for sine, and we could say that the sine of theta is the tangent of theta times the cosine of theta. And then I could plug in or substitute what we know for tangent of theta times the cosine of theta. But still, we need another equation to help us solve this. So we can go back to our original Pythagorean identity, this one here, and we can substitute this for sine. So we have negative 2.327 times cosine of theta squared plus the cosine squared of theta equals 1. And then we can combine like terms here. So if you square this number here, we get 5.415. So we get 6.415 here. And then we're just going to isolate. And then we could take the plus or minus square root of both sides. However, we need to, before we do that, we need to think about which quadrant we're working in. So if we're between pi over 2 and pi, we are in quadrant 2. So that means that cosine is going to be negative and sine is going to be positive. So when we take the square root of both sides here, we're just going to take the negative square root. So the cosine of theta equals the negative square root of 1 over 6.415. And then let's plug that into our calculator real quick. And we get about negative 0.395. So that's the cosine of theta. But then we do need to go back and solve for sine. So I can go back and actually substitute that in right here, over here. And when I multiply this negative by this negative, we do get a positive answer, which makes sense because our value for sine should be positive. So again, I'm just plugging that in. I'm substituting negative 0.395 in over here. And we get 0.919. So there you go. So that's one way you can do a problem like this. You can use that first Pythagorean identity, and you could use the ratio of sine over cosine to help you rewrite with tangent. Another way that we could go about this is we could actually use the Pythagorean identity that involves tangent. So remember that identity is tangent squared theta plus 1 equals secant squared theta. So we are given the value for tangent, so I could substitute that. So we know negative 4.366 squared plus 1 is going to equal secant squared of theta. So I'll plug this part into my calculator. We get about 20.062 equals the secant squared of theta. But we are trying to find sine or cosine. So I can rewrite secant squared theta as 1 over cosine squared theta, the reciprocal function. And then we can multiply both sides by cosine squared and divide both sides by 20.062. And then we would take the plus or minus square root of both sides, but let's actually decide if our answer should be positive or negative. So when we're between 3 pi over 2 and 2 pi, here we're working in quadrant 4. And I know in quadrant 4, sine is negative and cosine is positive. So our answer here should just be the positive square root. So cosine of theta is the positive square root of 1 over 20.062, and we could plug that into our calculator real quick. And we get approximately 0.223. And then there's different routes we could take to find the sine of theta. Since we know tangent, we could use that same starting ratio. Tangent of theta equals sine of theta over cosine of theta. So the sine of theta is going to be tangent of theta times cosine of theta, and both of those are values that we have. So it's going to be negative 4.366 times 0.223. So you plug that into your calculator. We get about negative 0.974. And it does make sense that our answer is negative because we are in quadrant 4. We also could have used our this Pythagorean identity. If you know cosine of theta, you can find sine of theta. So different ways you can go about it to finish this problem. So whether you are fully using this Pythagorean identity or if you want to use one of the other two, you absolutely can. It is up to you, whatever makes the most sense for you, or if you want to try both, go for it. All right, I have one more for you guys to try on your own, so please pause the video and give it a shot. All right, go ahead and check your work here. So here we are in quadrant 3. So in quadrant 3, both cosine and sine are negative, so both of our answers should be negative. So I use this Pythagorean identity first to solve for cosine, and then I use the other Pythagorean identity, solve for sine, to find the value for sine of theta. So if you did it a different way, that's totally fine, but you should still end up with the same answer. All right, that is all for today's video. Thank you so much for watching.